For the third problem in Chapter 12, we read, from a survey of 557 people, 378 said they preferred your product to your leading competitor. On a repeat survey of 335 people, taken a week later, 241 said they prefer your product. So based on the first survey, estimate the proportion of the underlying population who prefer your product. So we're talking about a confidence interval here. Give a standard error and a 95% confidence interval. Give your answer in terms that would be understood by someone not knowing any statistics. Okay, I put the basic numbers here just to speed things up. We had in the first survey 378 out of 557 people, which means that 179 did not prefer. And in the second survey we had 241 out of 335. All right, so we calculate proportions here is equal to preferred divided by total surveyed, and we get 67.86%, okay? And we can copy that same formula over here because we arranged the data to be able to do that. So we go from 67% up to 71%. That looks like an improvement. All right, but we still need to calculate the standard error. And to do that, standard error is equal to the SQRT, the square root, open, closed. And then I click inside and I say p hat, which is this one right here, p hat times, open parenthesis, 1 minus p hat. Okay, so there's that. And then the whole thing is going to be divided by n, which is 557. Oops, forgot the last parenthesis. Thank goodness for Excels. All right, so all is well. We came up with a standard error of 1.98%. From that, we can calculate the upper and lower bounds of a confidence interval. So that would be, for the lower bound, it would be equal to the mean, which is 6.7, minus 2 times the standard error, or 64%, and the upper one would be equal to the average plus 2 times the standard error. So it's from 64% to 72% is the 95% confidence interval for the true proportion of people that prefer my product. Now, because of the way I set it up, I can just copy it over here and get the values for the second survey. Now, what we're interested in, though, is the difference between the two. So for the second survey, the proportion is 71.9% that prefer my product. And so that difference is going to be equal to, let's see, the 71 minus the previous one. What did we get? We got an increase in 4.1%. All right. And the standard error of the increase is going to be equal to the square root, SQRT, square root, open, closed, click in between, of the first one squared minus the second one squared. So this would be this one squared no, it's plus the second one raised to the second power, square root of that. And what do we get? 3.15%. Okay, so what do we see? So the observed increase of this 4.1% is Well, let's see, how many standard errors is that? Well, we have to divide this equal to the proportion divided by the standard error, and we get 1.29. That's 1.29 standard errors. This represents an increase in support for my product, yes, but it's barely consistent with there being no true underlying increase. This probability of observing such an increase by pure luck is, we need a p-value, equals 1 minus norm dot s dot dist 1.29. Close parenthesis. Oh, I forgot to put in cumulative. So let's go comma, true, is 0.098. That's almost 10%. So the probability of observing such an increase by pure luck is about 10%. There you make your decision.